Let's look at OpenStax College Physics, Chapter 14, Problem 42. A. Calculate the rate of heat conduction through a double-paned window that has a 1.5 meter square area and is made of two panes of 0.8 centimeter thick glass separated by 1 centimeter air gap. The inside surface is 15 degrees Celsius, while that on the outside is negative 10 degrees Celsius. Hint: there are identical temperature drops across the two glass panes. First, find these and then the temperature drop across the air gap. This problem ignores the increased heat transfer in the air gap due to convection. B. Calculate the rate of heat conduction through a 1.6 centimeter thick window of the same area with the same temperatures. Compare your answers with that for part A. So let's write down the things that we know and what we're looking for, and I already drew a little diagram there. We'll write some more things on it. So we know in part A that the area is 1.5 meters squared. There are two panes of thickness. I'm going to call it L1 is 0.800 centimeters. Separated by a 1 centimeter air gap, so that's L2 is 1 centimeter. The inside surface temperature is 15 degrees Celsius, so that's T in is 15.0 degrees Celsius, while that on the outside is negative 10, so T out is negative 10 degrees Celsius. So in part A, we're looking for the rate of heat conduction, so Q over T. In part B, we want, now we have a thickness, I'll call it 3, is 1.6 centimeters. Same area, same temperatures. And for part B, we're looking for the different Q over T. So here in the diagram, I'm going to label some things. There will be heat transfer Q1 through the first pane, Q2 through the air, and Q3 through the second pane. So this would be temperature in, and this is temperature out. Let's call this temperature 1 and this temperature 2. Then we know that this is thickness L1 and this is also thickness L1. The panes of glass have the same thickness, and I'll call this L2. The other things we know are that conduction K1 for glass is the same, and then we have a different conduction here, K2. And we can get those from a table. So K1 for glass is 0.84 joules per second meter degree Celsius. K2 is 0.023 joules per second meter degree Celsius. All right, so as a hint, they told us that Q1 over T is the same as Q2 over T, and that's the same as Q3, which is the same as Q1 over T. So why don't we start by writing these things out? So I know that Q1 over T equals Q2 over T, and Q3 over T equals Q2 over T. So writing them out more explicitly, Q1 over T is K1 area T1 minus Tn divided by L1, and that's equal K2 A T2 minus T1 divided by L2. Then for this second equation, we have K3, which is the same as K1, it's for glass, so K1A, and the temperature difference is T out minus T2 divided by L1, same thickness as the previous pane of glass, and that's equal to the same that we have above here, K2A T2 minus T1 divided by L2. So one thing to pay attention to is that when I did the delta T's, I used T1 minus T initial, T2 minus T1, T out minus T2. So make sure that you keep them in the same order. Don't say T1 minus Tn and T1 minus T2. You want to keep them all going in the same direction. So one thing that I notice here is that I can cancel out the area. So I'll do that. And to simplify my equations, because it's quite a mess here, I'm going to say that K1 over L1 is A, and if I plug in the numbers, you would get 105 joules per second meter squared degree Celsius, and K2 over L2 is B, and that would be 2.3 joules per second meter squared degree Celsius. So I'm crowding things quite a bit here because I have a little bit of algebra to work out. So then I will rewrite these two equations, making those substitutions, and end up with A times T1 minus T in equals B times T2 minus T1, and then A times T out minus T2 equals B T2 minus T1. I'm going to add these two equations, and from that I will get A T1 minus A T in plus A T out minus A T2 equals B 2B T2 minus T1. The reason I'm doing this is because in the equations for the heat transferred, we have the delta T's everywhere. So here I have a combination of a temperature that I know and one that I don't. Those are both temperatures or a temperature difference that I don't know. So combining these two, I can find the T2 minus T1 as a function of Tn minus T out or T out minus Tn. So that is what is happening over here. I am going to factor out A, so I have T2 minus T1, and solve for the T2 minus T1. So here I have then A times T out minus T in minus A times T2 minus T1 is 2B T2 minus T1. So I'm going to combine this A T2 minus T1 with that T2 minus T1 and end up with A T out minus T in equals T2 minus T1 times A plus 2B. So then T2 minus T1, temperature difference between the two sides of the air gap, will be A times T out minus T in divided by A plus 2B. All right, so now that I have that temperature, I can use this equation to find the Q. All Q's are the same, so I can just find this one and say that it's equal to all the others. So Q 2 over T then is K2A, T2 minus T1, I'm going to plug that in a little bit. So K2A over L2, and T2 minus T1 is A T out minus T in divided by A plus 2B. And plugging in the numbers, notice that K2 minus K1, or K2 divided by L2 is, where is it? K2 divided by L2 is B. So this is B. And I know the value for that. So B is 23. I'm going to skip the units. Area is 1.5 square meters. And then I have A, which is 105. T out minus T in, that is negative 10 minus 15 divided by A, and that's 105, plus 2 times 23. Actually, that is 2.3. 2.3. Okay, so multiplying all these things together, we end up with negative 82.6 watts. So we know that 82.6 watts were transferred in this problem. Now in part B, we have a different pane of glass, and it has a thickness that is the 2L1 that we had before. So now Q over T will be K glass, area of the pane, times T out minus T in, divided by 2L1. So K1 was 0.84, area is 1.5 square meters, T out is negative 10, T in is 15, divided by 1.6 times 10 to the negative 2 meters. And when we plug in these numbers into our calculators, we end up with negative 1.97 times 10 to the third watts. So the heat transfer across just this pane of glass that's twice as thick as the previous glass is a lot more, which means that having the air between these two thinner pieces of glass is a lot better. There is a lot more insulation happening here. The heat transfer is lower than the heat transfer through just one thicker pane of glass.